Mission-critical performance doesn't happen in the cloud, it happens at the edge. That's why Intel sees dedicated computing as a key strategic partner. They take our edge, AI, and high-performance compute capabilities into ruggedized environments to support the mission on the edge. Workloads like XR simulation, AI inference, demand low latency at the edge. And this is exactly where Intel's roadmap is focused. Through deep engineering and validation collaboration, dedicated computing and Intel deliver secure AI-enabled solutions at the edge. At the end of the day, dedicated computing and Intel deliver one thing: real-time intelligence at the edge when it's needed most, when it matters most.
The importance of a unified value proposition for OEMs and integrators like dedicated computing is key to getting the mission done. At Intel, we stand behind our integrators 100%. The partnership between dedicated computing and Intel accelerates innovation through sharing of roadmaps and making sure that we take to heart feedback from both dedicated and also their customer base.
Intel's new Xeon processors are out there making a huge difference, especially at the edge. Because of new accelerator technology that we've built into the CPUs, we can now do a whole lot more at the edge than we've ever been able to in the past. Inference, specifically AI inference at the edge, is a reality in low power, low cost, and targets for specific edge type of workloads that you're working on. For example, object detection, LLMs even, in a nice tight package. And our work with dedicated computing is critical in bringing together a solution that is ready to go and available for everyone today through optimizing firmware and security built into a complete system.
We live in a world of OEMs, prime contractors, medical device manufacturers. We need to have systems that are mission critical. So if you look at what those systems do, we train pilots, we guide surgeons, we diagnose patients, and we provide insight into the battlefield. So these are mission critical systems that failure is not an option. So we work hand in hand with Intel. We get early access to their silicon, and then we design systems that are ruggedized and then deployed. And once they're deployed, they have a life cycle sometimes up to 10 years. So it doesn't end when we ship to the customer. We provide long-term support over the lifetime of the program. Take training and simulation. Right now when that pilot moves the joystick, the image that comes back at him has to be as realistic as possible. So with that said, we have to do real-time inferencing. If you take medical field, we're now looking at medical imaging. We're running AI on those medical images, and we're able to diagnose conditions much earlier without any post-processing. And if you look at the most important one, military, we're looking at insight onto the battlefield, trying to figure out where the enemy is and where we should deploy our resources. So with Intel, they have a state-of-the-art roadmap for CPU, GPU, AI, accelerators, and I/O. And then our ability to turn those systems into rugged systems and deploy at the edge, we're able to fulfill those needs and meet those demands head-on.
Mission-critical compute now sits at the center of modern simulation, training, defense, and medical applications. The performance and reliability of these systems directly influence readiness, safety, and outcomes. Intel has been a strategic partner for dedicated computing for over 3 decades. Their technology roadmap enables the high-performance, long-lifecycle, and scalable systems our customers depend on in their demanding environments. We build our platforms around Intel's roadmap so we can deliver solutions that are future-ready and aligned with what our OEMs need over the next 3, 7, and 10 years down the road. Ultimately, this partnership is about customer outcomes. Together, we help our customers improve safety, accelerate readiness, boost performance, and bring new capabilities to the world faster.